Mathematics at Init College, a YouTube channel for high school mathematics education. Mathematics 2C, Swedish high school education system. Hi, this is Babak. In this video, I'm going to solve the following problem for you. This is a problem on the topic of systems of linear equations. Let me read the question for you first. Solve the following system of linear equations. The first equation is 6 over x plus 5 over y is equal to 4. The second equation is 14 over x minus 3 over y equals 2. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you find the correct answers, the answer would be x equals to 4 and y equals to 2. Okay, now let us solve the problem for you. Of course, you see that I have written a system of linear equations, so this should be a linear equation, but of course we know that this is not a linear equation because I have my variables in the denominator. But the reason that I have categorized this problem under the same title of systems of linear equations because even though it is not a linear equation in this form, it can be reduced to a linear equation by introducing auxiliary variables. So here, what I will do, I will introduce two new variables. I would say let, for example, capital X be equal to 1 over x, and capital Y be equal to 1 over y. Okay? And then we replace these new variables into the original equation. So the first equation is actually 6 over x plus 5 over y is equal to 4, but we know that this can be written as 6 times 1 over x plus 5 times 1 over y equals to 4. But now instead of 1 over x, I can put capital X, and instead of 1 over y, I can put capital Y. So then the equation will read as this in this form: 6x plus 5 times y is equal to 4. So that is one of my equations now. Okay? And then for the same reason, 14x over minus 3 over y equals 2 can be written in this form: 14 times capital X minus 3 times capital Y is equal to 2. Okay? Now we can solve this new system and find capital X and capital Y instead. Okay? And when capital X and capital Y are known, I use these two definitions to find little x and little y as demanded in the problem. But if I now ask you what is this system, let me just form the system. It is 6x plus 5y is equal to 4, and then I have 14x minus 3y equals to 2. Now you hopefully see that this is a linear system of equations. Yes, it's a system of linear equations. And if I want to solve that, for example, I can use addition method. I can multiply the first equation by 3, and I can multiply the second equation by 5. Yes, then the first equation will give me 18x plus 15y equals to 12, and the other equation would be 70x minus 15y is equal to 10. Now if I add these two equations side by side, you immediately realize that these two are gone, and then what I get here, 18 plus 70 is 88. So what I get is that 88 capital X is equal. On the other side, I have 10 and 12. When I add them, it becomes 22. But now I want to make the capital X alone, so I divide both sides by 88, and then you know that we can simplify, and it is always better to simplify. We can divide the numerator by 22, it becomes 1. I can divide the denominator by 22, it becomes 4. So this is my capital X. Okay. Now, before going and trying to find little x and little y, let me just find capital Y here. So I refer to one of my equations, original equations here. I would think that this might be a little bit simpler to use, and instead of capital X, I just plug in 1 over 4 and find capital Y. So then I would say that the first equation would be 6 times 1 over 4 plus 5 times y is equal to 4. And then if I simplify 6 times, I think it's easier to multiply. Yeah, let me simplify first. 6 over 4 is 3 over 2, and then I have 5y is equal to 4. For example, if I want to get rid of the denominator, I can multiply everything by 2, so it becomes 3 plus 10y equals to 8. And then so 10y becomes equal to 5, and I want to make y alone, so I divide by 10, so it becomes 5 over 10, but this can be simplified by 5, and then I will get y equals to 1 over 2. So these are capital X and capital Y. But now my goal is to find the original variables in the problem, the original unknowns x and y, little x and little y in the problem. So what I have to do, I would say that x is equal to 1 over 4, and we also know that capital X is 1 over x. So from these two I can conclude that 1 over x has to be equal to 1 over 4, and this is very trivial, that little x itself is equal to 4, and this is exactly the number that is provided here by the problem itself. And of course I use this and this to find y, so I would say that again y is equal to 1 over 2, and y, capital Y, is defined to be 1 over y, so this means that 1 over y is equal to 1 over 2, and then you can get that y is equal to 2. So it means that, you see, I introduced two new variables, capital X and capital Y, and then this non-standard system is reduced to a standard system that I know how to deal with, and I solved that system and I found my variables, new variables, which I will call them auxiliary variables, and then using them I will go and find my original unknowns. Okay? That's also a good idea if we know how we can implement this problem in GeoGebra. So, for example, you go to GeoGebra, this is Classic 6 that I'm using, and then you have some views here. If you want to solve a system, you have to go to CAS view. Okay, so I will choose this view, and then of course there are some things that we don't need. We can go to this view again here, and then let us take this graphics out because we don't need it. Okay, now here I can put my input, so you start with typing solve with capital S. Of course there are some suggestions for you, so you see that here you see here solve list of equations, list of variables. So you choose this option, and then according to my experience it is better to push to click the delete button here and then open a curly brackets, because in GeoGebra when they talk about lists you have to put them in curly brackets, and you start typing your equations. So the first equation is 6 over x, and then I go type the other equation, the other term, which is 5 over y, and then so 5 over y equals to 4, and then you put a comma. It means that you are supposed to write the second equation. The second equation is 14 over x minus 3 over y, and then you have equal to 2. Yes? And now when you typed your equations, you go to the list of variables, my recommendation is to click on the delete button here, and then open a curly brackets to list the unknowns. The unknowns in this problem are x and y. This is it. And then you go there and press this enter. So you see that GeoGebra provides you x equals to 4 and y equals to 2. Okay, so I hope that this video has been useful for you. Below this video you will find the link to the PDF file of these notes. Until the next video, be safe and goodbye.